Throughout human history, scientists, philosophers, theologians, and others have pondered this beautiful gem called Earth, floating in the seemingly empty blackness of space. When Copernicus advanced the radical notion planets orbit the sun instead. Then, Galileo pointed a telescope skyward. In his observations of the moons of Jupiter, phases of Venus, and the craters of Earth's moon, Galileo provided startling new astronomical data that strongly supported a heliocentric or sun-centered view of the universe. Meanwhile, in Central Europe, each planet orbits the sun in a non-circular orbit known as an ellipse. Nebulae are created by the explosion of stars, which have exhausted their nuclear fuel. By studying the compositions of nebulae, astronomers have found evidence that stars and planets can form from these interstellar clouds. 99% of nebular material is composed of hydrogen and helium gas, but about 1% consists of tiny bits of solid matter, silicon compounds, iron oxides, carbon, and a host of other materials, all of which are found in the sun and planets. If the force of gravity between the gas and bits of cosmic dust is strong enough, this matter is gradually pulled together. As the nebula contracts, it starts spinning, heat setting its particles in motion. The further it condenses, the faster it rotates. The process is something like what happens when a skater condenses himself by drawing in his arms until his body becomes a blur. Gradually, the gas and stardust become more and more concentrated at the center of the nebula, heating up to form a star. The material spinning around a new star flattens into a disk, drawn there by gravity from the equatorial bulge created by the star's rotation. Over tens of millions of years, dust gathers as clumps in the hot disk. These collide and weld together under the influence of gravity, forming larger objects called planetesimals, which in turn come together to form the planets. The precise details of this accretionary process remain unclear,